Thank you. It reminds me when I sold 100 bitcoins for 500 euros. True story. Welcome to Hacking with Hardware. I'm so glad to be here at Smd Sizes again. It's a wonderful venue full of wonderful people. So, you already introduced me. My name is Pedro Umbelino. Currently, I'm a senior security researcher at Checkmarks, but I also do a lot of stuff on my spare time. Sometimes I write for Hackaday. I haven't written for some months now. I don't have the time, but I'm here as a hardware hobbyist. And I'm going to talk about hacking with hardware. So it's not going to be about hacking hardware. We are not going to try and figure out how to hack into your own router to change the DNS settings or whatever. I'm going to talk about hardware that was built with the purpose of hacking, specific hardware. And why do I want to talk about this? I think hardware gadgets are cool. If they are security related, even better. I think we all share like this common imaginary of somewhere there's some spies that have all these cool gadgets that can open doors or make an ATM spit money or whatever that Hollywood kind of implanted on us, and we want to build these devices somehow. I also wanted to share my experiences, my tips, my fails. So if you are starting now, you don't have to repeat my own mistakes. And the objective here is to try and bring more folks into the hardware makers community that have a security mindset. I think the community, the hardware makers movement already have started to grow in the security sense, so to speak. But there are space for more folks to come and have fun building cool stuff. Before I do the talk about what I was doing, what I am doing at the moment, I want to talk a bit about history. So I want to talk about historical devices that were built because it was the only way to hack into something. Okay, and I want to start with this guy, Marian Rejewski. He was a British magician and inventor, and he was probably the first wireless hacker. So this guy was a self-taught radio enthusiast. He built his own radios and antennas, and he was getting really professional because some of the antennas were like reaching 50 meters high. This was in 1903, around that area, in the beginning of the 19th century, of the 20th century. So he was a public detractor of Marconi. Marconi had a lot of patents about radio at the time, and I think he had a problem with that. Maybe he already had a bit of hacker mentality, and he didn't like those patents. So in a public demonstration that Marconi did, he actually built a radio, and he set up a small radio next to the West End Music Hall where the demonstration was going to happen. And he hacked into the demonstration by sending a Morse code message that was a very dirty poem. Some people found it funny, those who knew Morse code. He did it because he wanted to bring the attention that Marconi was saying that he invented a new method to secure communications via wireless, via radio in this case. And his idea was that if an attacker does not know the frequency in which the message was being transmitted, then he could not hear the message. So the only security was the frequency. For us now, it's pretty clear that's not a measure of security, but please keep in mind it was the early days of radio, and in his mind it was impossible to know which frequency a guy was transmitting. Moving forward, we got Marian Rejewski. So he was a Polish mathematician and cryptologist that invented the bomba cryptologica. This was at the early of the World War II. He was presented with a problem that the Germans were using an encryption machine called Enigma, and they had no way to decode these messages. So Rejewski reverse engineered the military Enigma only with a commercial version of that machine and some encrypted messages. So it was quite a feat. and then he built the Bomba Cryptologica, which was like 6 Enigma machines like glued together, so to speak, and it could crack the German codes, at least at first. Then the Germans changed something and it stopped working, and then Alan Turing built his own bomb, which was based on the Bomba Cryptologica. It was designed just to hack into the Enigma codes. There's too much to say about Turing and his contributions. I don't think we'd all be here, maybe, if it wasn't for his contributions. But then, also William Welshman made a contribution to the bomb that made possible to decrypt the German messages in a timely fashion. So again, a hardware that was built for the purposes of hacking, in this case, in the cryptology field. Now, moving on to the 50s, I want to talk about Joey Gracia, or Joy Bubbles. Joy Bubbles was born blind. And when he was 4, he discovered the telephones, and he was really into the telephones. For a blind kid, maybe there was not much to do at that time. And he discovered he could dial numbers just by clicking the on and off button on the phone. And when he was 7, when he was dialing a number, he noticed there were some tones he could hear. And he decided to whistle back those tones, and the call hanged up. So he thought, this is funny, something is happening. It turns out that he had a perfect 2600 hertz pitch while he was whistling, and he could effectively make the switchboard think that the call was disconnected, but continue to talk. So this was a way to have a free phone calls. And at the time, the phone calls were very expensive, especially long distance. So this guy didn't actually build any hardware. I think he had the hardware built in. He has a very nice story for those who, the older here, I think everybody knows about Joy Bubbles, maybe the younger don't. But this was the beginning of a revolution, the 60s and 70s golden age. So, the freakers back then, which was the phone hackers, there was a couple of guys, also blind, that contacted a guy called John Draper and saying, look, we have a way to hack into the telephone systems, but we have to carry around our whistles, or we have tape recordings of the 2600 hertz tone, and that takes too much trouble. If we had like some sort of box where we can dial, and that we can generate the tones, that will be very cool. So they contacted John Draper, also known as Captain Crunch. And John Draper had an electrical engineering background, and he built the first blue box. Now, the blue box was a tone generator. It could be used to a lot of stuff, including what Joy Bubbles first discovered. But then, from there, a lot of different boxes were made by freakers. It was a very prolific time building hardware into hacking systems. Like the red box would fool the electronic, it would fool the tool services into thinking that a coin was introduced at a paid phone. The orange box would allow you to change your caller ID. So a lot of boxes, the blueprints were online shared in the BBSs, and it was a very prolific time for hardware manufacturers, in this case, freakers. Now, in 1985, this guy called Van Eck, a Dutch researcher, published a paper about electromagnetic radiation from video display units, from monitors. And not only he published the paper, as he built a device it was essentially a screen, a decoder, and an antenna, and it could point the antenna to any screen and get the what's on that screen remotely without interference. It's also called tempest freaking. Auto tempest means specific things in the security field, but the security community was very concerned because that decoder could be built with around $15 of material. So there's also some videos online about a BBC program that was made. So this kind of vulnerability gained a lot of media attention, also like we see nowadays with some vulnerabilities. And the guy came to be known by Van Eck radiation, this kind of radiation. Later in '98, Paul Kosher, he was the principal designer of DeepCrack. DeepCrack was essentially a machine built to crack the DES challenges that RSA Security made back in 1997 to demonstrate that DES was broken, was not supposed to be used because it was no longer safe. So DES Challenge 2 was the first one that DeepCrack participated, and it was solved in 56 hours. DeepCrack was made of 1,856 ASIC chips, like soldered together, and it was the brain of DeepCrack. So there are a lot of examples. I'm very sure that some of them that are important I didn't mention, but we have to fast forward in time to get to where we are today. So several things were happening. Somewhere along the way, the internet was born. The community started to gain strength and switching knowledge from the BBSs into the internet. Also, the vendors started to produce more accessible devices. There were a lot of microcontrollers now that the hobbyists were using, like basic stamps, PICs, AVRs, Z80s, the 8080 also. So there was like a boom of websites that facilitated access to old parts or to exotic parts that hobbyists could not have access before. And then later on, Alibaba paved the road for the Chinese suppliers to flood the market with cheap materials and cheap stuff. So, at the same time, hackerspace movements mushroom in every major cities. Now it's a commonplace, everybody knows what an hackerspace is, and they kind of democratize the access to this knowledge and to the community access and sharing of knowledge. The Arduino helped to bring more students, and later the Raspberry Pi, and nowadays we have the ESPs that allows us to, as an hobbyist, to put Wi-Fi almost in every project, even if it's a toaster and even if that makes no sense. Online PCB makers are also an important part for the hobbyists, because now it's easier than ever to send your own PCB for fabrication at a price that is not prohibitive. And other fabricator services like 3D printing services bloomed. So now we are here today, and I think we live in privileged times for the hardware hobbyist. Okay, I think it's very easy for us as even if you're a hobbyist, even if you're starting now and you haven't like soldered anything, you can start. There are communities everywhere. The information is abundant. The parts are cheap, easy to find, and especially starting kits exist for most of microchips. For example, let's say you find out that the microchip has this particular function that you want to use in your project. Back in the days, you had to read all the data sheet and then use all the circuitry involved, the analog circuitry involved to make that chip work. And nowadays you can find that in starting kits, so you can test your idea before you're going deep into the analog part and the soldering part, which I think is something that scares people that, like most of us, have a very strong software engineering background, but not so much in electrical engineering. So sometimes we are afraid to start projects because we don't know where to put the resistor or the condenser or whatever. So the starting kits are also helpful. And I think for all these reasons, there was a boom of hardware that was built just with the security, or maybe to test security, in the last 5 years or so. So I'm pretty sure most of these devices, like the famous Rubber Ducky and Proxmart and Packet Squirrel over there. The USB killer, which is really stupid. But anyway, it's hardware and it demonstrates a security flaw or something. And you see there are more complicated projects than others. It doesn't stop them from being useful. I'm pretty sure you also know this little guy here on this corner. It's not an hardware project per se, but you grab a board and you put a display, and then you have an entire community around this device, which is quite funny. So This is where we are today. And what I want to talk about is my hardware build approach. I want to share it. It's something that's pretty straightforward. I'm not saying it should be adopted in any way. Your mileage may vary, but I think it's a good approach if you're trying to start to build a prototype. Not a product, but a prototype. So you can test your own prototype. And I will base this presentation on a pet project of mine that I started. Usually you have I have 7 different phases. Like the first one, motivation, is not really, well, it's a phase of the project, flow. The idea has to come from somewhere, right? There are people that keep getting ideas. Oh, it will be so cool if there was a device to do this or to do that, and or then the motivation comes out of necessity. Like I really needed a device to do, something. After you have that initial idea and that you want to materialize as a prototype, you have to go to the definition phase. For me, the definition phase is like to write down what are the features that I want in that particular device. I divide it by features. And after I have my features, I go research for the components or the parts that can help me implement those features on an actual device. And then I go into the design. I figure out how the pieces connect together and design the schematics and then the PCB. And so far, you don't spend a lot of money or almost no money. And then it starts the part that you actually spend a little money, which is sourcing the parts, figuring out where are you going to buy them from. Also the PCB, if you are ordering the PCB, if you are making it yourself, if you are ordering assembled, everything here has different costs and speed, of course. Then there's the fabrication part, if you're doing some parts yourself. Then the test, then the loop, if you're not happy with your device or you want to add some features, you go back to the definition phase and you loop it until you are happy. So, I'm going to talk about each of these topics using an example of a hardware that I built. So, making of Huberhead. The hardware is called Huberhead. Like, this idea has been brewing on my head for too long. This is part of the motivation, and there was a time that I actually needed that hardware. It would be nice to have. So since necessity is the mother of every invention, I decided I should start, building it. So this is your friendly Vodafone technician, that some of you know, that was doing a social engineering gig. So my task was to go inside a company's office, which I had no knowledge about the inside, and I was there to change the router for one of my own, which I had 2 days to build something together, because that's just a package squirrel inside the router. So what happened is, since I was going inside the building, I didn't have knowledge of what I was going to find. I carried a lot of different devices that I could drop or replace or put on a computer. And at some point I had like the rubber ducky on one hand and a Wi-Fi keylogger on the other hand. And I was like, this makes no sense. I have like 2 devices, and if I have like this one opportunity, only one opportunity to access a computer, I'm not going to insert the 2 devices. It makes sense that all these features, like if you have a bad USB injection device, and you have a keylogger, and then you have Wi-Fi, all these features make sense in only one device. Especially because if you have something like the rubber ducky and you leave it there, it's a bit conspicuous, I think, but you have, if you have something connected to the keyboard, maybe there's a better chance for that to go unnoticed. At least that was my reasoning, and that's why I actually started the project. That and another reason that I stayed there. So Huberhead is some kind of USB man-in-the-middle device. The idea is to have an input and an output, and to have a brain that can mangle the packets and do whatever he wants to do. But the initial application that I found out was to be a Wi-Fi keylogger and injecting at the same time. Also, since we are plugging in a USB device, it can also, mimic a mouse. and whatever heat devices that you can think of, if you do the firmware for that, of course. So I searched the usual suspects shop for this kind of hardware. I couldn't find anything quite like it. I found similar things, but I didn't find a project that involved everything. And I think this was the final motivator to start this project. But this should not keep you from also beginning a project of your own, in my opinion. So, as I said, this is an approach towards building a prototype, not a product. Okay, so I broke down the project per functionalities. I searched for existing parts that could perform some of all the actions that I wanted. Of course, if I found a part that performed all the actions, then problem solved. I figure out how you connect them, and then you read the fine documentation and datasheet or manual, depending, to make it work. So the functionalities here, this is the research part. The functionalities here, it's the keylogging part, the injection part, and the Wi-Fi part. So we have three major functionalities. And for that, for the injection part, I based on an Arduino Leonardo device. There's the Atmega that runs this device, can do HID injection, so problem solved. You can buy a lot of those clones of bad USB clones, like rubber ducky clones, for $3. It's not very expensive, problem solved. For the Wi-Fi part, I use the ESP8266. It's also cheap. I've used it before. It's powerful than Arduino. That's why I chose it to be the brains of the device. So also problem solved. For the keylogger part, I haven't worked with that before, so I researched a bit. I came out with this Max 3421 chip, which has SPI. I know that the ISPs speak SPI, so for me, it was just a matter of figuring out how can I make all these components talk to each other. Also, libraries already exist for the Max 3421 in the Arduino IDE, which I could use to program any device, the ESP and the Arduino. So, from there, we get to the design phase. My advice is, if you're starting something and you're not used to electronic design automation software, is to try at least a couple of them. And I'm going to explain. So, I don't think they are very user-friendly. Opinions may vary, but I don't think they are very user-friendly. And some things that you can do in one particular ADA, it's harder to do in another. And I think it's useful for you to try like a small project from start to finish until the PCB is made. In different EDAs, and elect the one that you like, and then continue to use that. It will save you a lot of time. And then, in the design phase, I think it's important to choose your parts wisely. You have to know if you are going to solder it yourself, if you are going to fabricate the PCB board yourself, or you're going to order the PCB. All of these things influence how you should choose the parts, because if you are going to solder them, it might not be a good idea to order very small parts and try to make the project very, very small, at least for a prototype, in my opinion. So, I chose Eagle. Yeah, I usually fail to listen to my own advice. But this is the project. It's the ESP connected to the Max 3421, which is USB host, which is the microchip that actually receives when you plug in a keyboard, receives the data. So, the important part here, as I was saying, is to know your package types and know the SMDs, and keep it simple. The simpler I think it's common sense. The simpler your project is, the easier it is to debug, and the easier it is for the EDA software to find the correct routes when you're designing the PCB. When I say package type, I refer to the mechanical specifications of the microchips. There are different package types, and each one makes it easier or harder for you to solder them if you are soldering yourself. So just to give you an idea, this is a list of package types for different microchips, and it goes on. So it depends if it's through hole or not. It depends the spacing between the legs of the microchip. Does it have legs? If you have an electronic background, you are familiar with this, but if you're not, sometimes it can be confusing. So, For example, about SMD sizes. SMD are the very small components on the boards. Sometimes it can get really annoying. For example, there are two codes when you are ordering, the metric code and the imperial code, and sometimes they overlap, which is really annoying if you're not specific enough when you're ordering, or if your supplier mixes it up. Because this is the difference between, if you order like the 0603 imperial code, you get a part that is 1.6 millimeters by 0.8 millimeters. But if someone switches the order, or you don't specify its imperial code and you receive the metric code, then you have to solder something that is 0.3 millimeters in size, and you aren't going to be able to do it by hand. Okay? So know your SMD sizes. My recommendation for me, what I found out that works better, is to use the 0805. It has 2 by 1 millimeter roughly, and it's quite I mean, you need pliers, but it's quite manageable, and you can replace the components by hand if you really have to. Some folks go for a smaller size. That's okay if you are used to if you don't shake much from your hands, and if you are used to solder. But I think it's a good start. Regarding package types, I think it's the same. If it had legs, I wouldn't choose a packaging type that has less than 0.5 millimeters between the legs. Otherwise, when you're soldering it, it gets stuck a lot of the times, and you have to be debugging. Sometimes it's, you short circuit something that's very small for you to see. You have to go with a magnifier, and you end up losing a lot of time. And in the end, if you are doing a prototype, maybe it's not so important that you're doing it like 1 centimeter bigger or smaller. So after that, you go to the PCB design phase, which is essentially a mapping of your circuit schematics into the proper layers of the PCB and the copper wires, so to speak, the copper traces. So I used Eagle. It has a cool outer root function. This is what I recommend for if you're choosing an EDA. If it has outer root, it's better for you. Outer root, mainly what it does is it translates these connections in the schematics to the proper copper traces automatically, and you don't have to draw it by hand. You can draw it by hand if it's a small project, but if it's a big project, it's really hard to do everything by hand. So if you're starting, choose one that has outer root, the outer root function. For me, Eagle was enough for this project, so this is kind of why I chose it. Did I mention to double check the thing before going into production? If not, please double check. After the design phase is done, please double check. If you don't, you end up with problems like this, where I switch the data minus and data plus and have in the first version, and then I fabricated 50 boards, and then they came and nothing worked, and then I realized I switched just 2 copper traces. In the end, I did the new device, and I cut the traces here with a knife, and I soldered some wires so I could spend some time programming while the others were making, and I wouldn't lose a lot of time. So then you got, right now, after the design and schematics, maybe you don't spend a lot of money, and now you are going to source the parts. I'm not here to promote any vendors, but I can give you tips after if you want. Just make sure you choose your PCB manufacturer, and you have to know if you have if you want to make a lot of boards, or because it changes between the cost changes if you are doing a lot of boards, of course. Some vendors have special prices for prototypes. There aren't a lot, but there are already vendors that you can say, okay, this is a prototype, build me just like 10 boards, and the prices would be very accessible. Some vendors receive the list of parts and they assemble it all, so you don't have to hand solder nothing. This is usually a more expensive solution, at least if you're doing a very limited batch. And if you're like doing some highly sensitive circuitry, you should go for high quality PCB manufacturers. Usually the Americans are good, and also the Germans. So my experience is that the most cost-effective way is to order the PCB and order the parts separately, and then you solder it yourself, because it's really not that hard. So when you order your board, if you're choosing that path, order the stencil. The stencil is this metallic sheet here that helps you position the solder at the right spots in your board. Because then the soldering task becomes easier if you use a hot air gun instead of the traditional iron to solder. It's not very difficult. You don't need like high-tech expensive gear. You just need to practice a bit. There are some kits available that you can buy to practice very small stuff soldering without you damaging your own boards if you want. Like that's the hot air gun that I use. It costs like 15 euros. It's very, very cheap. It's gas powered because I travel a lot and I like to have it with me. So it doesn't have temperature control or nothing, but it's manageable and you can use it in your projects. You don't have to spend a lot of money. And my two favorite methods to solder is the drag solder method and hot air solder. I had some videos. I'm not sure if you have time, but if you have, I'll show you both methods. So after all is done, you get to the testing phase. If everything works, it's tested. If not, at the first time, then you have to go test it yourself. So I don't use nothing fancy. That's the standard multimeter. The only thing that I like in a multimeter is that it has an audible function for continuity testing. So I don't have to be looking at the multimeter and the things that I'm testing. If I'm testing for continuity, there's some kind of buzzer that indicates me. That saves me time. If you have budget, get an oscilloscope. This one is DS203. It's like a portable oscilloscope. It goes around for 150. It's a bit expensive, and it's not really super necessary. And sometimes if you have a lot of integrated circuits, it helps to have a thermometer, because I've burned myself so many times. So it helps you identify which integrated circuits are overheating or not. And you don't have to use your finger. So essentially the testing part is you review the PCB and the schematics, you figure out if the relationships are properly well done, you analyze the board to see if everything is properly soldered, and if not, you just start to test each connection. So it's an iterative process. So this was kind of the loop cycle. These three here were the first components that I separated by functionality. So this was the Arduino Leonardo part. It was a ESP board with Wi-Fi, and this is a starting kit for the Macs. So I just connected a bunch of wires, too many wires actually, and tested if my IDE was valid or not, if I could make something work. As soon as I was sure that I could make something workable out of there, then I designed the PCB, the first iteration, which was flawed, and then I got to the second iteration, and then I got really excited and printed a 3D case and stuff like that, but you don't have to do it. So this is kind of the evolution of the hardware process for me. It's very early stage. In an early stage, it's not done, of course, but it kind of works now. So the Uber Heat prototype is an ESP8266 based USB keylogger that has keystrokes and mouse injection and Wi-Fi capabilities. So I started the basic firmware development. There's like injection capabilities for mouse and for keyboard, but like some features that I would like to see were like the part that you have the keylog management, password candidates, like if the keyboard is idle for too long, probably the first thing the user types is the password, for example. In injection payload functionalities management, like import payloads from other devices like the rubber ducky, why not? It seems like a cool feature. In the Wi-Fi section, you could have like access point management, Wi-Fi scan to scan for nearby access points. You can have a text like, for example, let's say if you want to know the Wi-Fi password, right? In a way that does not interfere with the computer, so to speak. So you can launch the authentication attack to the computer, that the Uber Eats is connected to. If you do it times enough, then the operating system will require you to re-enter the password, and then you get the Wi-Fi password without even running code in the computer or running a command to grab the password and then send it back to you. So I think the features are just your imagination is the limit to the number of features that you can add to this thing. So I wanted to show a demo, but in fact I was afraid that the time was not enough, so I've been demoing this the whole time because I have one disconnected to my computer. And this is the web interface that's connected to the computer, so I can, go back and forward. I can show you like the typomatic rate of the thing here, for example. Yeah, so it types really, really fast. So it could be faster, but then it would be complicated for the serial connection. Sometimes the keys could drop. So also like running commands, like opening a browser. It was too fast to show on screen. It opened the browser for my GitHub just by clicking a button. This is features that already are available. And this project is open source, the hardware part and the software part. So if you want to join in, feel free. There's a lot of stuff that we could do. Let me just go back to the presentation. So, demo, yeah. So I think my final words are, we live in a fantastic time to tinker with hardware, okay? I think the security community is getting its well-deserved gadgets. There are a lot of projects already, but I think there's space for more projects. I think there's a lot of potential for the security-minded folks to come into the hardware makers movement and do a lot of more gadgets that we need and we deserve. There's so much more to be invented. And my idea is to try to inspire, if you ever thought about making hardware, to do that jump, to leap in, to join in. I think it's easier than ever to do it nowadays. So this would be my final words for the presentation, except for one thing, which is kind of awkward. So while I was searching for images for that slide with a lot of different hardware, I went to my friend David Sopo's hardware list. He has a very nice list of hardware, and he also links to other people's hardware lists. And then I was browsing around and I saw something called Keyval board. Anyone knows what a Keyval board is? No one. Okay, I feel a bit better. So the Keyval board, this guy, Luke Plemakers and Mattis Vogel, I think, invented Keyval board. And it can do pretty much what Uber Eats proposes to do, and they started to commercialize this like some months ago. So I don't have a Keyval board. I didn't order one yet. I noticed by the pictures that they use a different USB host chip. But they also use the 80 mega. They have a SIM version and they have a Wi-Fi version. From what I read, the brain, so to speak, of this software is the Atmega, which limits a bit of the things that you can store there, has a lot less memory. But essentially, the idea is kind of the same. And it's nice to see that the hardware kind of flowed all in the same direction. I was a bit pissed off having found this out like 1 week ago, of course. But I had to do the shout out. It's a nice product. I'm happy that I learned about this project just last week. Because knowing me, if I have learned this like a couple of months ago when I started Huberhead, that would probably be a demotivator. But I don't think that would be good, because the things that you gain going through the experience of imagining something, designing on paper, then going through the EDA and building the schematics, ordering, the entire process is quite fun to do. It's very rewarding when you actually build something almost by yourself and then you see it working, and if it has like some sort of community potential, even better. And probably I would miss that experience if I figure this project a bit sooner. So anyway, there's the shout outs. I want to thank really quick some folks. I want to thank Hackaday, Mike from Hackaday, because being in touch with Hackaday allowed me to and write about hardware projects, allowed me to keep my hardware skills a bit sharper, I guess. I want to thank Jason Ingalls, because he was a huge supporter of my first hardware projects. And overall, thank you, Aris, for your kind words, and David Sopas, we all miss you here. We'll see you next year, I'm pretty sure. Thank you for your support. Thanks. Questions? By the way, thank you. By the way, I have some Huberhead kits, like the actually hardware that you can solder yourself. I bought a bunch of different components, and I have some that if you're interested in the project, if you want to try it and you want to solder yourself, please come find me. And I don't have a lot, but if you are interested in participating in the project, I will give them to you. Okay. Thank you. That's it.
So, does anybody have any questions?
Questions? Yes.
Show of hands. Yeah.
I wondered what your first project was, because you mentioned that there was someone in particular who helped you through your first hardware project.
Yeah. Well, my first real hardware. I had the first project a long time ago, but my first real hardware project that I went through all this process was called MICLOC. It was a piece of hardware designed to figure out which were the positions of gunshots. It's strange, but it has a background. I had some hunters hunting near my house, and I wanted to figure out where they were. So I made something that triangulates the position with an array of microphones. That was the initial idea.
Anyone else? I guess not. So wait, on the back.
So I wanted to ask regarding the Wi-Fi antenna you placed on the board, the planar antenna. How did you copy it? Did you go through the process? What's your process to reaching that level or that layout for the antenna?
You're talking about the Wi-Fi antenna.
Yeah, in the
ESP module.
Is it part of the module, or did you copy it?
No, it's part of the module. I didn't design that part. That's the wonderful thing. You can just nowadays you can buy different modules. I mean, of course, if you're doing a project like a professional project, you should hire at least one electrical engineer, electronic guy with strong backgrounds, properly designed circuits. But if you're working in prototypes, you can just choose the components and choose components that already do some part of the work that you need, and just you figure out how to connect them. And that way you kind of cheat and bypass all the analog circuitry that you need to know, kind of. That's why I always try to bring all my projects into the digital world where I can easily manage them instead of fighting with the analog part of the project, because I don't have an electrical engineering background at all.
Hi, Pedro. Nice to meet you.
Hi. What's up?
I want to know if you have any plans on planting a mic on your device, because it should be very interesting. And I don't know.
Well, I think you can ask that as a feature. Join the project, and in the hardware design part of GitHub, you just plant a mic. I didn't thought about mics. I know there are at least one device that does something like that records the sounds. Well, who knows?
Hello. I know it's an open source project, but are you planning on selling the mounted product for those that don't have the skills to mount it themselves or buy the hardware?
Well, I don't know. I think it depends on the interest. I'm not going to say that the idea did not cross my mind at some point, but right now I'm more worried that people work on it and it's an open platform, because there's no really open, maybe there is, my research skills are not very good. But I know that at least this platform hardware is open source, the software is open source, we can work on it and build something. Maybe it makes sense to offer a mounted version of it, an assembled version, but given that everything is going to be open source, I'm pretty sure the Chinese will do it for me pretty fast, so I don't know.
Okay, thank you.
Any more? No? Because we wanted to say something about hardware you brought with you and David, maybe?
What? Sorry.
The trade you wanted to do?
Oh, yeah. So David had this awesome idea about if you have hardware that you don't use or gadgets that you don't use, for us to all bring it to B-Sides and have a table maybe at beer sides later on. And
Where's the CTF? We'll have some table.
And if you want, we could trade like old stuff or old electronic stuff. Maybe it's just you and me, David, but we will be there trading our own stuff between each other.
I have a USB pen I can trade.
Perfect.
Okay. Thank you, Pedro. In the meanwhile, so you can clap. Yeah, sure.
Thank you.